Welcome to Ask and Learn.
This problem is about a guy who has 13 pair of shoes, each pair a different color. So to simplify our counting problem here, what we're going to do is pretend like he only has 4 different color pairs of shoes: red, green, blue, and black. Once we figure out how to do it with 4 pair of shoes, then it'll be easy to extend it to 13 pair of shoes. Okay, in the first version of the problem, they want to know in how many ways can he pick a pair of shoes, a right shoe and a left shoe, with no restrictions, meaning he can have the same color shoe on both feet, and that the color that he has on each foot matters. So a red shoe on one foot and a green shoe on the other is not the same as if you flip them around. All right. So we have 2 things that he's got to do, 2 tasks. He's got to first pick a right shoe, and then he's got to pick a left shoe. Okay, since he's doing 2 things, that leads us to the product rule. He's going to pick a right shoe. And we'll put how many ways he could do that. And then he's going to pick a left shoe, and we'll put how many ways he's going to do that. He can do that, and we're going to multiply them together. Well, he's got 4 choices for the right shoe: red, green, blue, and black. So we'll put a 4 here. And then for the left shoe, since there are no restrictions, he also has 4 choices there: red, green, blue, and black. So 4 choices. So by the product rule, 4 times 4 is 16, which says there are 16 different pair of shoes he can make. In terms of a tree diagram, here's how it would look, or part of it anyway. He could wear a red shoe and a red shoe and a green shoe, red shoe and a blue shoe, red shoe and a black shoe. So from the red shoe on the right, there's 4 choices for the left shoe. And then similarly, from the green shoe, there'll be 4 choices. From the blue shoe, there'll be 4 choices. From the black shoe, there'll be 4 choices. So 4, 4, 4, and 4, that's where the 16 comes from. All right, in the second version of the problem, now what we want to do is put a restriction on there. And the restriction is that colors cannot be repeated. So we cannot have a red shoe on both feet. Okay, but still, order matters. A red shoe on the right is not the same thing as a red shoe on the left. Okay, but he's still doing 2 tasks. He's picking a right shoe and a left shoe. So again, we have the product rule: a right shoe, a left shoe. All right, so again, how many choices for the right shoe? Still got 4: red, green, blue, and black. Now, once he picks a color for the first shoe, for the right shoe, then he only has 3 choices for the left shoe. For example, if he picked a red shoe for the right, then he cannot pick a red shoe for the left, but he could pick a green shoe, a blue shoe, or a black shoe. So you can see he's got 3 choices for the left shoe. So in total, he has 12 different pair of shoes he can make. Okay, now in the third version, we're going to say, again, there are restrictions. Colors cannot be repeated, but this time it doesn't matter what color shoe is on which foot. So a red shoe on one foot and a green shoe on the other is the same, no matter which shoe is on which foot. So this is equivalent to picking a set of things. That means we can use combinations. First of all, we're choosing a set where order doesn't matter and nothing can be repeated. That's the tip-off that it's a combination problem. So we're going to do a combination. We have 4 colors, and we're going to choose 2 of them. Combination, 4, choose 2. Okay. And if you work that out, it turns out to be 6. So let's look at these different choices and see how this works. Okay, so his first choice would be a red shoe on the right, a green shoe on the left, a red shoe on the right, a blue shoe on the left, a red shoe on the right and a black shoe on the left. All right, so that's all the choices you can have with a red shoe on the right. So then what if he had a green shoe on the right? Well, he can't have a red shoe on the left because that's the same as this one. Remember, in this version of the problem, doesn't matter, red and green is a pair of shoes, doesn't matter which shoe is on which foot. Okay, can't have green and green because we said no colors can be repeated. Okay, so he could have green with blue and green with black. Green with blue, green with black. All right, now what if he puts a blue shoe on the right foot? Well, if he puts a blue shoe on the right foot, he can't put a red shoe on the left because we've already got blue and red right here. If he puts a blue shoe on the right, he can't put a green shoe on the left because we've already got blue and green right here. He can't put blue and blue because no colors can be repeated. So his only choice is blue with black. I'll squeeze it in over here, blue with black. All right, well, what if he puts a black shoe on the left? Well, we can't put black with red. We already got that. Can't put black with green. We have that. Can't put black with blue because we already have that. Can't put black with black because no repeating. All right, so there's the 6 choices that you can have right there, same as what we got right there. All right, in the last version, it wants to know, okay, let's take the restriction off. Now we'll say colors can be repeated. So we want to think of this one as an addition problem. Okay, we have how many ways can colors be repeated, plus how many ways can you pick a pair where colors are not repeated. Okay, so we'll have repeat. I'm going to just put REP, REP plus not repeated. Can we know the not repeated amount is 6 from the one right above it? And the number of ways he can repeat the colors is he can have red with red, green with green, blue with blue, black with black. 4 ways there. Plus the 6 ways from part C, 10 different pairs of shoes. These 6 plus red with red, green with green, blue with blue, and black with black. Okay, so what if he did have 13 pair of shoes? Now what are we going to do? Okay, well, we'll just follow along, do exactly the same thing. In the first one, there are no restrictions. He's got 13 pair of shoes. It matters which color is on which foot. Okay, so he's got 13 choices for the first shoe, 13 choices for the second shoe. Okay, in the second part, that first part, that matches with this. In the second part, we're going to have no repeating. So he's got 13 choices for the first shoe, 12 choices for the second shoe. All right, for the third part, no repeating colors, and order doesn't matter. It's picking a pair of shoes. All right, it's a set. It's a combination because there's no repeating. Order doesn't matter. There are 13 colors to choose from. He's going to pick 2. So it's C, 13, choose 2. All right, and then the last one, let's take the restriction away. He can repeat colors. So all we have to do is figure out how many ways he can repeat and then add it to whatever we got in part C. Well, if there's 13 pairs of shoes, then he could have red with red, green with green, blue with blue, 13 pairs for repeating. Plus whatever C13 choose 2 is, because that's how many ways you can pick them so that they're not repeating. So now you can extend this to however many pair of shoes that you want. It'll work the same way every time.